degree of freedoms in HyperMesh, type of 1D elements, CAE process, 1D analysis formula. In session 4, we will learn how to create a 1D rod element, how to define materials, how to define property, how to define constraints and loads, how to define the analysis type, and how to view the results. So we will start with a problem statement of a rod element subjected to tensile force. So here you can see the cross section of the rod element, which is a solid circle of a diameter 50 mm. The length of the element is 500 mm and the loads and the constraints are also defined here. Now we also have the material property defined here, that is the Young's modulus and Poisson's ratio. This is for a steel material. Analytically, we have calculated the stresses as well as the deformations since we have the formula for those. Now the reason why we have calculated these stresses and displacements is because so that we can verify our results from the software. So once we solve it in HyperMesh, we should be able to see whether the results are correct or not. So now let us go directly into HyperMesh. So once you install HyperWorks, to start the software, all you have to do is go to Windows, that is go to the search option in Windows and simply type HyperWorks. As soon as you type HyperWorks, there should be something called as HyperWorks Desktop. So click on HyperWorks Desktop. Once you click on HyperWorks Desktop, a window will open. This is HyperMesh window. Here you will have to choose a user profile. So user profile is nothing but which software or which solver do you want to use. So we want to use OptiStruct solver all the time. So all the time we are going to select this option only and click on OK. Once you click on OK, now we can start modeling using our 1D analysis formula. But before we go there, first let me show you the overview of the UI, that is user interface. So we have some toolbars here. Top toolbar here, the vertical toolbar is here, and then there is one more horizontal toolbar at this position. Now on the left side we have something called as the model browser. Here at the center at the bottom you will see all the panels, and now on the extreme right side on the bottom these radio buttons are called as pages. So now let us start with our process, that is MHPCLL. So the first process is M. So for that we will go to this icon in the toolbar, that is materials. Click on that. Next make sure you are inside create. Give a name to the material, change the color, type as isotropic, card image as mat1. Now click on create/edit. Now we have to define E, new and row. So E stands for Young's modulus, nu stands for Poisson's ratio, and rho stands for density. So these are the default values. Now click on return. Again click on return. Next process is H, which stands for HyperBeam. So go to 1D page, HyperBeam panel. Go to standard section. Go to this drop down arrow and select the standard section. In our case it is solid circle, and now click on create. As soon as you click on create, it will open up HyperBeam where you have to define the value of radius, which in our case is 25. Once you define the value of radius, it will show the cross section on screen. If you want to fit this to screen, you can go to this icon in the toolbar. And now to go back to HyperMesh, you have to go to this icon under model. Now once you are inside HyperMesh, again click on return. So HyperBeam is also done. Next process is property. So go to the property icon. Again make sure you are inside create. Give a name to the property, let's say rod. Give a color to the property. Type as 1D. Card image as P rod. Material as the one we have created earlier. Same goes for the beam section. and now click on create. So MHP is done. Click on return. Next step is C, which stands for component. So again in the horizontal toolbar, go to the component icon. Make sure you're inside create. Give a name to the component. Give a color. In property, select the property as rod and click on create. Now click on return. Next we have to create some nodes. So to create the nodes, go to geometry page, nodes panel. First we will create a node at a coordinate of 0, 0, 0. So click on create. The second node we will create will be at a distance of 500. So x of 500, y0, z0. Again click on create. Now if you want to see the nodes on the screen, go to this icon on the toolbar which is fit to screen. And now click on return. Now we can create the element between these two nodes. So go to 1D page, rods panel. First give a property. Second, choose element type as C rod. Now we will select the nodes. So first node, second node. So our element is created. Now click on return. Now we will remove these temporary nodes. So go to geometry page, temp nodes panel. Click on clear all. This will delete all the nodes from the model. And click on return. Next we will define our loading condition. So MHPC is done. Next is L, which stands for load collector. So go to this icon in the toolbar. Make sure you are in create. Give a name to the load collector. We will give the name as SPC. SPC stands for single point constraint. Give a color. In card image, choose no card image and click on create. Now click on return. Now to define the constraint, go to analysis page, constraints panel. First select the node where you want to apply the constraint. So on this node I want to apply the constraint. Make sure all these degree of freedoms are checked, which means they are fixed. So DF1 all the way up to DF6, they are all checked and there is 0 in front of them. Now load type is set to SPC. Click on create. So our constraint has been defined. Next go to return. Now define another load collector which will be for force. Change the color. Again no card image and click on create. To define force, go to analysis page, forces panel. Select the node on the right side. Select the direction by going to this drop down arrow. In our case it is going to be x-axis. In magnitude you can define the magnitude of force, in our case which is 10 e raised to power 5. That is 100,000 Newton. Now click on create. Next we will click on return. So constraints and loads are defined. So L is done. So MHPCL is done. The last step is also NL, which stands for load steps. So in analysis page, go to load steps panel. Make sure the type of analysis is set to linear static. Give a name to the analysis. Check SPC, and in front of SPC click on 0 and choose the SPC load collector. Similarly, check load. In front of load click on 0 and choose force load collector. Now click on create. Now return. So here all the steps are done. Now all you have to do is save the file and solve the file. So to save the file, you can go to file, save as, and here select model. Give a name to the file and click on save. Once the model is saved, go to OptiStruct under Analysis page and click on OptiStruct. As soon as you click on OptiStruct, it will start solving the problem. It will open up a new window where it will show you all the information. So here it says analysis completed without any errors. Now you can see the results. So if you want to see the results, simply click on results button. Once the results are loaded, go to the contour icon in the toolbar and click on apply. So by default, the software is showing the results of displacement. If you want to align this rod in XY plane, you can also click on this icon in the toolbar, which is XY plane view. And here you can see on the right side, the maximum displacement is 1.2 10 to the power minus 1, which is 0.12. And on the left side, the displacement is 0. Now if you want to see stresses, under result type, you can choose element stresses. In the second drop down, make sure it is set to C-rod stresses and click on apply. So here the software is telling me that there is a uniform stress of 5.093 10 to the power 1, which is 50.93. So here we are done with the problem statement. Now I am going to show you the homework. So in homework, you will have to solve the same problem of a rod element subjected to tensile force, but this time the parameters are going to change. That is, the cross section is going to change, the material is going to change, the force is going to change, and the length is going to change. So these are the 5 problem statements, and these are the last 5 problem statements for a total of 10 problems. For 10 problems, you will have to solve the stresses and displacements analytically, that is using formulas, and also using the software, that is using HyperMesh. This is just to make sure that whatever you are doing in the software is correct, so you can verify from the analytical solution itself. So here we are done with session number 4. Thanks a lot for attending session number 4. In session